Hello everyone, welcome back to our Solidworks course. In this video, we would be starting with a new module. As you have read already, the name for our module is 2D drafting. In this video, I would be introducing you to the 2D drafting. What is drafting and what are the features that Solidworks provides in order to create 2D drafts or rather 2D drawings. Let's first discuss about what is drafting. Drafting is nothing but creating drafts. And what are drafts? Drafts are documents. In the manufacturing world, documents are 2D drawings. We provide these 2D drawings to the manufacturer so that he can develop our 3D model, or he can create a 3D model using various manufacturing procedures that he thinks are right or optimum for that product. So here, with the help of a small sketch, let me explain you or show you how the process of drafting works. First, we have a sheet over here, let's say, of any size. We can choose a sheet size of any, let's say A3, A4, A2, A1, whatever, the size which can accommodate your draft or rather your 2D views. Next, what we have to choose is that we have to choose the model for which we would be creating a 2D drawing. Let's say in our case, we have a cube. Let's say we have a cube over here like this, and we want to generate a 3D or rather a 2D manufacturing drawing for this cube. We will add some 2D views onto a drawing sheet over here. Let's say I will supply the manufacturer with a view of our 3D model from this direction, that is the front direction. So I will add a front view over here. As it is a cube, it would be the 2D view would be a square. Also, let's say I will provide him with a view from the top side over here like this. Again, it would be a square as it is a cube. Another, I will provide him with a view from this direction over here like this. Now the views we have added over here have some names, that is, this is the front view, this is the top view, and this is the right hand side view. The orientation in which I have arranged my views is called the third angle projection method. If I divide all of these into 4 quadrants, you can see that the front view has been added into the third quadrant. And this is why we call it the third angle projection method. From the front view, we have specified the top view over here. You can see it aligns according to our views. The front view is over here. The top view, that is this face, would obviously come on the top of the front view. And from this face, that is here, that is we are calling the right hand side view, would obviously come on the right side of the front view. If you open, or let's say if this was created by a simple cardboard, and if you try to open it, it would look something like this. This would be our front view. This would be our top view over here. This would be my right hand side view. This would be my left hand side view. And this over here would be my bottom view. That would be another view which would be from the rear side view. Or sorry, it would be called as the rear view. Here you can see that this is how I have arranged my views over here. And this is the method that you should follow as well. There is another method which is the first angle projection method. If you are comfortable with that, you can look it up on the internet and you can use that. But I am comfortable with using the third angle projection method. I hope now it is clear how do we specify the views for a product. Also, in drawing sheets, another thing that is most important, or other that should be your first priority while creating the 2D views or 2D drawings, is that your dimensions. Your dimensions would be of the utmost importance because based on that, the manufacturer would be creating your 3D model. Let's say I will provide my dimensions over here like this. I want a cube of side 50. So all of the sides here would practically be 50 millimeters. This is what we provide. Also, you can provide something which is called as center lines like this in order to tell your manufacturer that this is where the center lies and this is how they are being divided along the center, showing the symmetry. Next, here we can also add sectional views. Let's say you want to add a sectional view about this section over here. You will simply note over here that on the top view, I want a section over here like this. You will specify this sectional plane over here, and in this side over here, you will get a view over here, which would be having some hatches showing that this is a sectional view, and you will take a look at it from this direction, that is from this side over here. This is how it would look as well. This is the sectional view, or rather the sectional top view. I hope here you got a gist of how your drawing works and what should be added to your drawings. Once we have done this, we will move to Solidworks and take a look at how things actually work in the Solidworks drawing sheet. Here, I will first launch Solidworks and then create a new drawing. It can be done in a similar way as we were creating parts. I will press Ctrl N, and here it asks me to create a new Solidworks document. From here, you will double click on drawing. Once we have done this, here you can see that it is asking me the sheet format that in which I want to create my 2D drawing. Let's say I will select A4 and see landscape. Once I have selected this, you can see that my sheet has been loaded. These things that you can see over here, that are these tables and the border, are my sheet format. This is for a later video. Let's first focus on how things work in a 2D drawing. First, I will select a simple component that I have created previously. I will browse for the component from here, and I will select this cube that I have created. You can see here that this is how it has loaded my cube over here, and now it is asking me in order to place the views for my cube. I will simply, let's say, place the front view over here. If I move my cursor upwards, you can see this is how the top view is being added. If I move my cursor over here in the right side, this is how my right hand side view would be added. Now I will click on OK and then generate my views. You can see this is how my views has been added. This is my front view, this is my top view, and this is my right hand side view. If you want to open this part into the 3D model or 3D view, you can simply click on this view over here, and here it gives you the option to say open part. Once I open my part, you can see here this is how my part was looking. Now I will relate all the views that we could see over here. You can see that this is the view, or rather the front view that we have added. This was a top view from this direction, and this was a right hand side view. I hope now it is clear how the views are being added. I will clear off all this and press Alt Tab in order to get back to the sheet. Once I have done this, what I will do is that I will get back to the sheet over here and then show you the next most important feature over here. Now that we have added all the views, we will move forward and dimension it. You can see here that we have a Smart Dimensions command over here. It is also available in annotations. It is also available in Sketch. I will go to Smart Dimensions and simply select this line. You can see here again, if I double click over here, this dimension would be added. So this is how simple you can add dimensions to your drawing views. This was one dimension. I want to give another dimension to this line over here. I will now again click on this line and click on the screen again. This is how your dimension has been added. You can also relocate these views by simply selecting this and then moving it downwards. You can see that here these two views have been aligned together so that they are moving together when I'm trying to move one. You can move this over here as well, as you can see here. This can move horizontally independently, but if I want to move this in the upward or downward direction, I have to move this one as it has given alignment over here. Same for this one. I can move it in the Y direction independently, but I can move it in the X direction because these two are projections of this front view over here. Now that we have added our dimensions over here, we will move to the next thing. Now let's say I will move this downwards a bit. Now let's say you have added all your views and you want one more view to be added. You can simply add that from over here that says the view palette. In the view palette, it is asking me to refresh. Okay, it has not loaded the component. If you go to this drop down over here, it will ask you for which component or the views or for what component do you want the views. Here we have our cube over here. We will select that. And here you can see that it has loaded all the views that you would be requiring in order to create this drawing. I will select isometric view from over here, drag and drop my isometric view on this place like this. You can also change your appearances for the views. Let's say for isometric, I will select shaded with edges. This will show me a realistic view of my cube over here. Now, this cube over here has a through hole from the center over here. We can see that over here, but it is not quite visible in this view or in this view. For that, I will select this view. You can see that there is an orange dotted line around it. I will select that view, and then let's say I will give it a appearance that is hidden lines visible. You can see it is showing me hidden lines that are not being visible from the top. These hidden lines are the lines for the hole that we have created on the inside. Again, I can select this view over here, and again I can select hidden lines visible. Now it is very clear that this cube has a circular hole in between. Or rather, you can read it from here that there is a feature which is not on the surface, but there is something on the inside. You can read all of these all together, and then you figure out that there is a through hole in this cube. This is also very clear from over here, but it was not clear that this is a through hole. This view and this view over here shows you that the hole is completely through the surface or completely through the body. Now that we have learned about adding our views over here and also about dimensions, let's move to adding annotations. In annotations, one thing that is important is the center mark. You can see here that a center mark has been already added over here, as it was previously made, or it was previously set in the drawing format that the center mark should be added at all holes. Let's say I will select the center mark, delete it. Now you can see that we have a center mark. We don't have a center mark over here. For that, I will select center mark. Here I will take an option that says for all holes. You can also add center marks for all fillets and for all slots. But we have only a hole in this model over here, so we will select for all holes. And I will hover my mouse over here and select this orange dotted line over here. That is for our view, drawing view number 1, as it is showing. I will select this view, and you can see that it is showing me a preview of how the center mark could be added. I will click on OK and generate this center mark. This center mark can be used in order to define your circle from these edges. Let's say I will again get into the Smart Dimensions command, select this edge over here and select this edge over here. You can see that it is giving me another dimension which is for the center of the circle. I can also give the center distance vertically. I will select this line over here, select this line over here and give it a dimension that is from the center. Here you can see that whatever dimensions I had given in this cube are being specified over here by only selecting the entities that I want. Once you select the entities between which you want the dimension to be generated, it will simply derive the dimension from your 3D model and place it over here. The next reference geometry over here we have is a center line. In order to create a center line, you have to specify two edges or two lines between which you want to create a center line. Here you can see that I have selected these two lines and a center line was automatically added. Next, say I want to create a center line between these two lines over here. I just have to simply select both of them and the center line would be automatically added. I will click on OK now that I have added all the center lines I wanted. You can also change the length of the center line. If you click on the center line, it will show you two endpoints over here. You can drag them around and move, or rather change the length of a center line according to the way you want. The same can be done over here like this. I can change its length. If it is overlapping something, you can change the length and then set them so that there is no overlapping between any other feature. You can press F on your keyboard in order to fit the sheet to the screen, or rather this window that we are using. Next thing we will learn about here are the drawing views. Remember I told you about a sectional view? Now I will show you how a sectional view is created. I will select this section view option over here and then specify where I want my section to be placed. I want it right at the center over here. You can see that it is snapping onto the center automatically giving us the option to create a sectional view right at the center. I will place it over here. I will click on OK, and you can see that this is how my sectional view has been created. Now I will place my sectional view somewhere over here, click on OK and generate my sectional view. I will show you how to read the sectional view. A section has been taken about this plane over here. It has created a plane AA. This plane is cutting my cube from this direction. I will show you with the help of a sketch. There is a plane AA over here created and it is cutting. Okay, I will zoom out a bit. I will clear all of this, and now I will show you. What it is doing over here is that it is creating a sectional plane over here like this. And this plane and this body is being cut about this plane over here. And you always get a sectional view normal to the plane that you have used in order to cut it. So when you take a look from the normal direction to this plane, only the parts, or rather only the faces that were in the same plane as this cutting plane over here have been shown in hatching, where the faces over here where there is no hatching are the part where there is no material, indicating that there is a hole over here. This is where sectional views come handy. It shows you internal sections, or rather internal features wherever you have created the sections. Now here you can also change the way you want this hatching to be. Here if I click on the hatching, you can see here that it is creating the hatching according to the material. We can also change it the way we want. Let's say I want it according to DIN 128 cast iron. I will specify the scale for my hatching. Let's say 4. I will enter it over here, and this is how you can see that it has changed. Let's try another one over here. I will say DIN 201 grey cast iron, and from here let's say I specify 3 as the scale. You can see this is how it has originated over here. I will first clear this drawing over here. Now this is how you can see it has created a hatch over here. You can also change the degree of your hatching. What does it mean by 0? For now it is inclined at 45 degree. 45 degree is the traditional way, or rather the conventional way of creating your hatching. You can also tilt it from this angle over here. Let's say if I make it say 45 again, you can see that now it has become vertical. So it has tilted by 45 degrees, and what that has done is that it has created a hatching that is vertical. Now again I will set it to 0 because 45 is the normal or conventional way of creating hatching. I will click on OK, and this is how you control your hatching over here. You can see that the description for this view has been added, that is at section. This is a sectional view and it is taken at a section that is AA. Now that you have learnt about sectional view, we will learn about what is a detail view. Let's say I click on detail view, and here it will ask me on what section of your sketch you want to create a detail view. Let's say I want a detail view over here like this. What I will do here is that I will drag my cursor away and then create a small circle over here like this. Once I have created the circle, you can see that this is how my detail view is being shown. Now what is a detail view? Detail view is nothing but an enlarged section of this sketch or view that you had created. Let's say you had some special feature over here. Let's say you had a small hole over here like this, and you did not want to specify it over here because it would have been, the dimensions would have got overcrowded over here. So what you did, you took a special detail view over here and then you specified the dimensions of your holes separately. Now what you can do is that you can specify the dimension of your hole from this end. Let's say it is at 2 millimeters vertically, and also it is at 2 millimeters horizontally. So this is how, in these situations you can use a detail view. You can select a small snippet or a small region of your view and create a view or specify the details of your drawing separately so that nothing gets overcrowded. It is always a good practice in order to keep your 2D drawing as neat and as clean as possible. Here we have some options for detail view. You can also specify no outline, that is no outline for your detail view. This is the section of my sketch that I have brought over here. If I untick this and select full outline, you can see that it is showing me a full outline of this circle over here and how or in what way my detail view is being shown. It is just a preview option. It is just an option in order for aesthetics. You can choose from all of these aesthetics over here. Once you have done adding all the dimensions, you can completely define your sectional view and then we will move forward. I will first clear all of these things over here. I hope that you've learned about creating sectional views or rather detail views over here. I will press F and set the sheet like to fit my window over here. The next option that you need to know about is first we will exit the detail view by pressing escape. The next option that you need to know over here is the break view. Now I will explain you break view with a simple example. First I will, let's say, just minimize this drawing over here and then I will sketch over here. Let's say I have created a part that is very long and it is not fitting on the sheet over here. But you want to specify all the dimensions for your part. What I will do is that I will create a break view. Now what is a break view? Let me explain it to you. Let's say I have some features over here like a hole like over here, a rectangular hole over here, and there is nothing over here. This part is not fitting on my sheet over here. So what I will do is that I will specify a break view over here like this. What this will do is that it will eliminate this part over here and then create a smaller version of this part like this. It will have only the two holes and from the break section it will have a small break over here like this. And it will show you only the parts that you have included. You can add multiple breaks in your part over here like this. It will then again shrink your part much more. Okay, it will basically shrink your part furthermore. The number of breaks you add would be resulting in shrinking of your view. I will show you this by in the drawing itself. I will first clear all of this and then again press F in order to set it or rather fit it to my window. Now let's say I am in the break view window. What I will do is that I will select the drawing view for which I want to create a break view. Let's say I will create a break view for the right hand side view. I will add my first break over here, move my cursor and add my second break over here. You can see this is how it has only shown the region of my view which is outside the break section. You can control the gap size over here. Let's say I want a gap size of only 2 millimeters. If I modify the gap size, you can see that this is how my gap has been shrunk. I will press escape and exit the break view. I hope now it is clear that how you use break views. Once you have done this, now we will move forward and take a look at what happens when you try to edit your 3D model. Do you have to create all of this over again or not? Let's take a look at it. I will select this view and then from here I will select open part. Let's see, I will double click on this over here and then edit the diameter of my hole. I will make it 20 millimeters from 25. I will enter 20, press Ctrl Q and then here you can see that the changes have been reflected. If I select this edge, you can see that it shows that the diameter is now 20 millimeters. I will again press Alt Tab and then get back to my view over here. I will press Ctrl Q in order to update my drawing. Now I will get into Smart Dimensions and take a look if the drawing has been updated. I will give a dimension to this hole over here. And here you can see that the drawing has been updated. You didn't have to change any of it, you just had to simply add the dimension over here. Again, let's get back to our 3D model and now try to change it again. Now let's say I make it 15 from 20. I will press Ctrl Q, rebuild the part, press Alt Tab, get back to my sheet over here and you can see that here again it has updated itself. So whatever changes you make in your drawing are being reflected or rather whatever changes that you make in your 3D part are being reflected in your drawing as well. You don't have to create the drawing again and again. Once you have linked your drawing to the 3D model, it will keep updating itself. Unless you have made any major changes, like you have deleted these faces over here, let's say you have created a circular cut over here and anything of that sort. If until all the faces are present over here, it will be giving all the dimensions here. Let's say you create a chamfer over here like this. What you do is that you create a chamfer over here like this. Then you have lost this point from which you are giving your dimension. There it will be giving you an error. Let's see what happens when we do that. I will first clear all of it, press Ctrl Tab and then get back to my 3D model. From here, let's say we want to give a chamfer to this edge over here and I want the distance to be of say 5 millimeters. I will add another chamfer over here, click on OK and let's see what happens now when we get back to our drawing sheet. Here you can see that it has automatically modified the dimension over here. As this was a very simple change, you can see that it has automatically modified our dimension to set it from 50 to 45. If it is a big change, it can at times get messy and you have to give your dimensions again, but that's it. You don't have to add this view over and over again. Once you have added this view, whatever changes would you be making in the 3D model would be reflected in your views. I will press F on my screen, set it so that it fits to the window. I hope now that you have got a fair introduction of how do we create 2D drawings and what is the workflow in order to create the 2D drawings. Also, I hope that you've understood how to use all the features that I've shown you till now. I will see you in the next video where we will learn about creating your custom sheet format and creating your custom sheet template. I will see you in the next one. Thank you.